Okay, so yes, good evening, everyone, once again. So today we're basically going to be moving further into Kotlin, and we're going to be talking about lists in Kotlin. Yeah, we're going to be talking about lists in Kotlin. So we've talked about earlier on, we talked about some basic data types, Kotlin, listen, ints, Kotlin int, double. I've made use of Boolean, we've made use of string, okay? And they actually just allow you to store a certain type of value within a variable, okay? But what if you want to store more than one value, okay? What if you have a lot of values you want to put in a container, in a variable? Okay, so that is where list comes in. That's where the list data type word comes in, okay? So what is a list? Basically, a list is actually a collection of items with a specific order, okay? It's a collection of items with a specific order. And then you have two types of lists in Kotlin. You have the read-only list, which is just list. So let me just share my screen. So I'll just be typing one or two things as we go ahead. Okay, so there are actually two types of lists, like I was saying in Kotlin. You have the read-only lists, which is just lists, okay? And this list cannot be modified when you create it. You cannot, when you create this list, you cannot modify whatever you've put inside. Okay, whatever series of values you've stored inside, you cannot modify it when you have created it. Okay, now the second type of list, okay, is called the mutable list. Mutable list. This is the second type of list, okay, and this list can be modified, okay, after you have created it. So that means you can actually add a value, you can remove a value, or you can actually update its elements, okay? So another thing we need to note is this: when you are using a list or a mutable list, okay, you must specify the type of element that it can contain. Okay, you must specify the type of elements that it can contain. Now, for example, assuming you're using list, now you can actually just specify, let me just use this as a pointer, okay? So for a list, you can actually specify by saying list, and then you do this. So basically, what are you saying? You're creating a list that holds a list of integers. Okay, you're creating what? A list of what? Integers. So the only values that are allowed in this list, okay, are integer values, okay? You could also have a list of strings that stores just what? Strings. Okay, so this is very important. Okay, so now a simple example is, now assuming I define a class called car, okay, like a car class, okay, you can actually have a list of car, okay, and this is going to hold a list of car objects, okay? Remember, I've talked about classes and what objects. So if I create a list of a class car, I'm basically creating a list of the object instances of that class, okay? So we're actually going to let's just do a practical stuff now. Let's actually implement stuff. So that's enough for the theory. Okay, so yes, the equality sign and the greater than sign, I'm just using that to itemize stuff. Okay, it's not really something in the sense, just to point to what I'm trying to say. Okay, thank you, Judah, for answering that. Okay, so let's actually look at this in practice. Okay, I'm going to create a variable numbers. And this my variable, I want it to be of data type lists. And what values do I want to store in the list? Integer values. Okay, and then, so what have I done? I've actually just declared a list called numbers. So numbers now is a list that holds integer values. Numbers is a list that holds integer what? Values. Okay, so now how do we now store values, store those integer values into numbers? How do we do that? Okay, so it's easy. We just use a method called list of. You can see you have a list of, and then you now what? Pass in the elements, okay, the values. So since we are dealing with integers, I can say 1, and then the next one is separated with a comma, 2, 3, 4, and then 5. Okay, so this creates a what? List of integer what? Numbers. Now, another thing is this. It's you can actually just infer the data type. Okay, like I could actually do the same thing by not having to explicitly declare this. So this is you inferring. So your compiler actually just knows, based on the fact that it knows what this is. It's able to just say, okay, fine. Well, I know what you're actually storing a list of integers. So it's either you create and you declare and initialize like this, or you just go straight into doing it like this. So this is more of an explicit declaration, and this is more implicit actually, if I'm free to use those words. Okay, so let's actually so probably we could just use okay, maybe I'll just comment this out and let's make use of the other one. So I'm going to, so let's see what we have when we print this out. So I'm going to say print line. Okay, Emmanuel, I'm coming to answer that. Okay, so let me just say list, and then so can I remember where? Okay, yes, and then call my numbers. Yes, okay. So Emmanuel, you asked if we can use one. So this is actually a range. Okay, 1 through to 5 is actually what? A range. So no, we can't. So well, let me actually just, it's better to show you. So we'll try it out and then let's see the outcome of that. Okay, so let me run this and then let's see if we can get, yeah. So we get a list. This is our result, a list of these numbers. So, okay, so Emmanuel asked if we could do this. Well, let's see. Okay, so let's run this. Okay, so you see that, of course, it's an error. Why? Because your inferred type is int range. That is what you're bringing in here is a list of, this is a range of numbers. So if I do this, let's just play around and then change this to int range. Okay, so let's see how this. So you get to see it here. Okay, so this is this actually denotes what? A range. It's an integer what? Range, a range of integer numbers from 1 to what? 5. So we cannot actually use it on an int because there are two different what? Data types. Okay, so I believe that answers your question. Okay, so moving on. So there are a lot of things we can actually do with a list. Okay, we can actually retrieve the size of a list. Okay, we can retrieve the size of a list using a property called what? Size. So I can actually say numbers. Now remember, we created a variable. Okay, this becomes a list. Okay, now I can actually use this to call several methods, okay, on this list, of which one of them is size. This is a property of, size. So let's see how this works. So, okay. So I need to put this, save this, and then, okay. So let's run this, and then we see, yes, 5. Okay, the size of this list is what? 5, because it contains 5 numbers. Okay, that is actually one of the things we can actually do with lists. We can actually get the size of the list. So let me just do this so we have something a bit more. Okay, and then Okay, good. So, okay, let me just, so we can have two things, good. Okay, so numbers dot size. Okay, so I just want us to be able to see the list, and then we now see the size of the list. So here I could just say size of list is, okay, and then maybe I can just take this out, and then we have a very pretty statement. Okay, size of list is what, 5. Okay, so that is that. And then so now another thing about list is this: how can we assess the elements of a list? Okay, how can I be able to assess 2? How can I be able to assess 3? Remember, a list is just you storing series of what values. Okay, so think of this as your wardrobe. Okay, you have hangers in your wardrobe, probably 8, and then your clothes are being hung. So you have probably 8 shirts in your wardrobe. Okay, so how are you able to assess probably the 4th shirt? How are you able to assess the 3rd shirt? So the 3rd shirt, probably the one on 3rd hanger from left to right. Okay, so how do we assess elements in a list? So that's what we're going to be talking about. Okay, so we assess elements in a list by its index. Okay, we assess elements by what we call by its index. That's how we assess elements. Okay, so let me bring this down. So good. So we assess elements by its index, and this index is basically an integer number that represents the position. Okay, so the index represents the position of that element. So now looking at this, you have this list. Okay, now the question is, of course, 1 has a position, 2 has a position, 3 has a position, 4 does, and then 5 does. So that position, we can also call it the index. So the index of 1, the index of 2, the index of 3, the index of 4, and the index of 5. So now the index is in list. Okay, the index is actually an offset from the first element. Okay, the index is, okay, let me just write it down, is an offset of the first element. Okay, that is the index. So what does this mean? So for example, when I say something like list and then use this, so list, we use square brackets. Okay, we use square brackets. So when I do something like this, what am I saying? I'm not asking for the second element on the list. No, I am not asking for the second element on the list, but I'm asking for the element that is in the second position, offset from the first. That's basically what I'm saying. So if I'm to do maybe list and then put 0, this is the first element. Okay, 1 is the second element. 3rd is the 1 is the 0, 2 is 1, 3 is 2. Just like for some of us who actually did computer science. Okay, we count actually from 0 down instead of starting with 1, 2, 3, 4, 5. So arrays and the rest, they actually the first element is usually has an index of 0. So the same thing applies to our list. Okay, so let's actually test this out and see if we are right. So I want to print let's say the first element. Okay, first element. Okay, and then let's just do something. So okay, in order for me not to just, okay, sorry, I think I can close this. Okay, just copy this. So now I want to do this. So for this numbers being the list, okay, I want to get the first element. Okay, so this is basically it. And then when I run this, this should give me 1. First element is 1. because 0 is not telling you what it's telling you is the word position. And for a list, okay, the index starts from 0. So that means the first element has an index position, an index or a position of 0. Okay, so let's actually just try out something else. Let's say, so let's find out what is in the fourth index. What elements do we have in the fourth index? Okay, so let me run that, and then we have what, 5, because this is the 0, this is 0, 1, 2, 3, and 4. So let's try 5 and see what happens. We have an exception in what's thread and the whole lot. So index, we have this array index out of bounds exception. You're out of bounds. You don't have a fifth element. You don't have a fifth element in the, based on the index. That is basically what it says. Okay, so that's actually how to assess. One of the ways you can assess what elements. We use the index. We use the index to assess the elements. Okay, yeah, so the elements at the position 2 or index 2, so 0, 1, and 2 is 3. So if you have any question, of course, you can just drop it on just raise your hand, or you drop it on the chat, and then we'll try to work that out. Okay, so moving on. Let's see. Let's try another. Let's try a series of, series of stuff we can actually also do with a list. I want to try something. So another thing we can do with a list, okay? Another thing we can actually do with a list is to print the last element. Okay, is to print the last element. And you can actually do that by saying numbers.size, since size is a property you can access, okay? And then you say -1. So this will actually give you the last okay, so this, okay, so there are two things. We can actually look for the last index, and we can look for the last element. Okay, we can look for the last index, and then we can look for the last element. So let me, okay, this should be third. Okay, sorry. Yeah, third. Okay, so now let's look at this. So I want to get the last index. That's the last position. Okay, the last index is the last position. This is how I actually get it. So when I run this, I get to know the last index. The last index is 4. So remember, we have 0, 1, 2, 3, and 4. But what if I want to get the last element? Okay, what if I want to get the last element? Okay, so what I'll basically just do is let's change this to elements. Okay, so what I'm actually now going to do is to get, I'm going to say numbers, which is this, then I'm going to now say numbers dot size and close this up. Okay. So what does this do? The numbers dot size already, this guy, which is the same thing as this, gives us the last element. So so since our last element is 4, that means the whole of this is actually 4. That is what it basically means. The whole of this is going to give us 4. So we are basically just saying numbers at index, the elements rather at index 4. So that should give us 5. Yes, the last element is 5. Okay. Okay, so someone is asking, what if the list started from 0? Would the last index still return same answer? Okay, so when you say what if the list starts from 0? Okay, let's try it. So we're saying basically, let's do this. So let me say 0. Okay, good. This is I want to believe this is basically what you're saying. If the list starts from 0. So let's run this and then let's see what we have. So your first element is 0, your third element is 2, your last index is 5. That's the last index, 0, 1, 2, 3, 4, 5. So probably let me change the number so you can actually just not think that we are doing a countdown here. Okay, good. Yes, so our last index is 5. That's the last position here. 0, 1, 2, 3, 4, and 5. And then the last element is what? 5 also. Because here we get the size and then we subtract the size of the element of the list rather, minus 1. And then we now, whatever we get, we use it to get the element. So that, I think that answers your question. Okay, so there are other methods we can actually call. There are other properties we can actually make use of. We can actually use, I can say print line. And then, sorry, that should be good. I can say, okay, so for now, I'm going to leave a lot of, I'm just going to say, okay, let me just make it. Let's do this a bit fast. I'm just going to call numbers dot first. This is also another method you can actually call on the numbers variable, or the list rather, that we have actually what's called. These are properties and methods you can actually call on a list. You can get the first element. So I'm just going to print that, and the first element is 0. We can actually get the last element also using the dot last method. Okay, and that should give us 5. Good, you can actually see that. Okay, so now another thing we can also do is to notice another actually useful operation is a method called contains. Okay, so this method is used to find out if a given element is in the list. So, like for example, if you have a list of employees in a company, okay, you can use this method to find out if a particular name is present in that list. Okay, so how can we do that? It's pretty simple. I'm just going to say print list.contains. Okay, now what do I want to check if it contains? What do I want to check? I want to check if it contains 8. I want to check if it contains 8. So let's see what the result of this will be. Okay, so sorry, contains. Okay, so yes, so it's false. It gave us a word false. So it returns a Boolean, returns true or false. Okay, now so it's, of course, we know that our list does not have 8 in it. So let's try a 9. And then I'm going to run this. And it's true. Our list actually contains a 9. Okay, so that's actually just a few things you can actually use with a list. Those are a few operations you can actually perform on a list. Now, like I said, if you have questions, just raise your hand and I'll stop to answer those questions. So moving on, we said that lists are read-only. Okay, you can't actually add anything to it. You can't modify it. Lists are read-only. So let's test that theory. Let's test that theory. So I'm going to actually just take out. Let's take out all this. Okay, and then I want to. Okay, let's just basically take this out. Let's try something else. Okay, let's try something else. Let's use color. Let's now play with. Let's create a list that now takes strings. So I'm just going to say list of. So you can actually watch the names. Okay, the first one, small letter, and then the next word starts with a capital letter. Okay, so a list of, so strings, remember strings, we actually put them in double quotes. So the colors, let's say red, let's say black, and let's say white. So let's just start with this. So let's see. So after this, now remember we said lists are read only, so we should not be able to add anything to it. Okay, so adding to a list, actually we make use of a .add method. Okay, we make use of a method called just .add. So like I can now say colors, right, dots. Now these are, you can actually see some methods, and you can actually call here, and there's a lot actually. So but what we need is say .add. Let's see, and then what color do I want to add? Let's say I want to add blue. Okay, so let's see. Let's see how we can do this. So let's run this. Okay, so yeah, this error says that the add method does not exist for what list, because you are not allowed to change the value of what an element, so it does not work. This method, when you say unresolved, means it doesn't even see, it doesn't exist. So there is no add method for a list. Okay, and well, but let me just show you another way you could even want to add. You can actually add based on a particular position. You could just say colors, and maybe you want the first element to no longer be red. This is you modifying. You now want the first element to be yellow. Okay, so this will also not work. You can see the second one, unresolved reference. Okay, none of the following candidates is applicable because the receiver type, because of receiver type what mismatch and everything. So it doesn't work. Okay, it doesn't actually work. So let's actually just take that out. Let's take that out, since we now know that in list, for a list, you cannot modify it. So let's see now, there are actually a few number of operations on lists that don't actually change the lists, okay, but will return a new list. Okay, they don't change the list, but they return a new list. And two of those operations are the sorted and reversed. So the sorted actually returns a new list where the elements are sorted in ascending order, while the reversed will actually just give you a new list, okay, but in the elements will be in a reverse order. So let's try it out and then see what we have. So I'm going to just go straight into printing the results. I'm going to say, let's say reversed list. So let's use this. Let me just, and then so I'm going to say colors dot reversed. So we should have, yeah, we have that method. It exists. Wow. I need, sorry, colors. Okay, so let's okay, yeah, let's print that. Let's see what the result is. So okay. I needed to close this out. Okay. Okay, so this actually just prints this. So what do we need to do? Let's see. I think, am I making any mistake here? Okay, so red, black, white. Let's run this again. Okay, so it still gives us red, black, and white. So something tells me this is okay. So let's try something. And then let's see. So let me print out. Let me just print out the color. Okay, yeah, colors. Okay, so let's do this. So let me run this now. Okay, so this just gives us the list, and then, okay, reversed. Okay, so for some reason, this is not reversing it. So let's see. It's supposed to give us a new list, actually. So let's try that again. Hope. So it's two things are involved. It's either this environment not giving us what we need to reverse. Should we use this or this? Okay. Let's. Okay, so yeah, I think I know. Okay, so let's see. What did I miss? I thought I did something reversed. Okay, so there are two. Okay. So let's see. Well, we have a lot of stuff here, but it should be this because this returns a list. So sorry, I might have to change the environment to be sure because I know this should actually work. Red, black, white. Let me see something. And then let's see if that's, so it's not print this, it's not giving us what we want. Okay, so let me see, let's take out this and then let's just have, okay, let's see how this still gives us back that same list. So that means this method is not being called. Okay, so I might have to change an environment for this. Okay, so there's a lot of environments we can actually use to test that out to be sure that, so let me see. Let me look at the Kotlin playground. Okay, so I want to try this here to be sure that I'm actually, okay, so let's try this here. I'm just going to copy this. Okay, so this is actually this is also Kotlin playground, but this is from Android, developer.android.com. Okay, so I think everything looks fine here. Okay, but we're still having this. This is one of the reasons why I said I love errors. Okay, so we'll move on and then I'll get to figure this out later. Reverse. Get to figure this out later. Okay, yes, thank you very much. Yes. Now I actually see the issue. Yes, so this is, we actually put this as one string. Okay, yes, we actually put this as one string, but they are different. So this is what we should have. Yes, thank you for identifying that also. Yeah, thank you. So, and then, yeah, man, you need to pay attention sometimes when you're writing code. Okay, so running this, okay, so expecting an element, yes, sorry, reversed. Okay. Yes, so you have white, black, blue, and then the reverse gives us a list, blue, black, and white. Okay, so should we keep on with this? Maybe we should just continue making use of this, young man. Okay, so that's one thing. So the other thing we can actually, the other method we can call that doesn't really change the list, but returns a sorted list is the dot sorted. So if I just change this to sorted, and run this, I should have a sorted list. Okay, black, blue, white. So we have blue, black, and then white. So let's try that again to be sure. Okay, yeah, so this is, it's actually sorted it in ascending order. Wow. So what does it actually, how does this look like? So let's look at this with numbers. One, for the sorted, let's actually use numbers. Let's try 1, 7, 5, and 8. Okay, so yeah, we're going to use colors. Let's just see how the sorted does it. Okay, so it sorts it out. Okay, yeah, it actually sorts it out. So it did that before. 1, 5, 7, and 8, and then this is we just printing the list. So let me take this out so we can. Okay, so we can stay, yes, 1, 5, 7, 8, ascending what order. So if I'm to move these guys back to what it was, take this out. So we should see black, blue, and white. Yes. Yeah, ascending order, BL, BL, A comes before U. Okay. So if I'm to add probably green at the end here, sorry, I should be, if I add green, so I should have black, blue, green, and then white. Okay, so that's actually what sorting. That's actually what sorting. Okay, so that's that. So we've actually looked at what lists, and we talked about the fact that lists cannot be what you can't actually modify it. So let's look at the one that you can modify, which is actually called the mutable what lists. Okay, so mutable lists, they are lists that can be modified after you have created them. You can add, you can remove, or you can change items. Okay, in fact, you can do actually everything you can do with read-only list as well. You can do everything. You can also sort, you can also reverse. Okay, and how do we create them? Okay, it's very simple. All I'm just going to say is mutable list of. Okay, that's actually how you create a mutable what list. That's how you create a mutable list. As simple as that. Okay, so sorry, mutable. Okay, yes, and that's actually it. So with this list, I can add, I can remove, and I can do a lot of things. I can even change an item. Okay, so but just before we skip to this place, let me just show you just for so how do you create it? The same thing for I can say color. If you want to do explicitly, if you just want to declare, how do you declare it? You say colors, and then you can now say of type mutable list. So this is how you declare it, okay? Mutable list, and then you decide what kind of values should be stored in that what list, okay? So this is how you actually create, declare a list, okay? So this is you saying you want it to be of type this, but it's not really necessary, actually. You can also you can just go straight then. So it's a mutable list string, and then we call the constructor. Okay, so this is actually not necessary because by Kotlin is actually smart enough to know, okay, fine, for you to actually put this in, for you to offer this value, okay, that means this variable can actually take these words, take only that stuff. So this is you just declaring, and then this is you initializing, okay? Okay, so let's move on. Let's move on. So what can we do? So let me actually just go. Let me take this out. Let me take this out. I want us to just go slow and steady, okay, so that we don't actually miss a thing. So let's see, and so let me just run this. Let's show you something. Now, if you can see this, it tells you no value passed for what? Parameter size, no value passed for parameter init. So init actually talks about initialization, okay? So we didn't actually give it a size, but yet we're actually creating this variable here. You know, whenever you use this, you're declaring and assigning at the same time. So you have assigned that, okay, you've said this variable is going to take a list, but you have not actually talked about the size, okay? So one of the ways, okay, to actually take off this error, one of the ways you can take off this error, okay, is to, okay, probably, can actually just do this. Okay. Now, so one of the ways to take away these errors, so it's either you use that way or you can just do mutable list of. So the other one is actually being seen as a class, okay? So let's look at this now. You have this here, okay, of course it's not used. Now, let's do this. If I now, I want to print this. What do I want to print? Let's say I want to print colors, okay? I just want to print colors. So let me say colors, and then let me call my color variable. Just want to do this. Okay, so running this, what should we have? You can see we have this brackets here, square brackets. So this is actually telling you that, look, colors as of now is an empty what list. Okay, colors as of now is an what empty list. So how do we add to this list? How do we add to it? Well, I'm just going to do it straight in the print line, but you can actually just do it separately. So I can just do it by saying colors.add. And what do I want to add? I want to add a color. Let's say white. Okay, so I'm going to have to do this. Okay, so running this now. Okay, true. So it gave you true because now it has actually performed that. It has actually what added it. But we want to actually see the list. We want to see the list. So to see the list, I'm basically going to say, I'm going to call colors. And then I'll call the list itself. I'll call the list, which is colors. Colors is the name of the list. So this just tells you that, look, this operation went successfully. I have successfully added, a color, okay? But to actually see that list, I have to not call the list, and calling the list, I get to see what white, okay? So now remember we said that it is modifiable, okay? So we can add as much. So I can actually just do this also. Can just double click and then let's say blue. Okay, and then let me print this again. And then we have, white, and then we have what's blue. Okay, so let's move on. This is just a little thing we can do. So now another thing we can also do is to we can actually just create more items. So let's do this. Let's do this. Let me create another list. Okay, I'm going to create another list now. I'm going to say, let's say more items. Okay, and I want to actually create this list, but I want it to not change. So I'm going to use list of. Okay, so let's say these are colors I don't want you to change. Let's say red, and let's say gray. Okay, let's just make use of these two. So this is me creating a list that cannot be changed. Now, what if I want to add, the contents of this list into these colors? How do I do that? Okay, it's actually pretty simple. All I'm just going to do, I'm going to say print line, and then let's make a statement, add list. So what do I want to add? First of all, I need I'll say colors. Okay, so let's actually put this. So colors dot, now I'll use a method called add all. I'll use a method called what? Add all, and then I'll pass in more items. So this basically should add every element in that list into my new list. So let me print that out. So let's now see the list. Let's see if those two have been added. So I'm going to run this. Okay, so we have an error here. So it's expecting this somewhere. Where is it expecting it? Okay, where is it expecting? Okay, at the end here. Okay, that's fine. Unresolved reference print line. Okay. So I think this closes. Okay, I think I can take out. That's interesting. Okay, so better just take this, cut this, take this. Let's just. Okay, so. Okay, so I think I'm just going to have to take that again, colors, and then gonna need, okay, so colors, and what are we adding? So we want to say colors dot add all, and then what we are passing in, what do we want to add? We want to add the more items. Okay, so yeah, I think this should be fine. Okay, yeah, so we now get to see this. So let me just, okay. So yes, we basically now see this. We have white, we have blue, and then it added the whole of this into this list, and then we have red, and we have what? Gray. Okay, so this is actually very important. This seems like, okay, we're actually just writing code, but trust me, we're moving into recycler views, and you need an understanding of lists to be able to create even create lists in your application. Okay, so we can also remove an item from a list. Okay, we can remove an item from a list. So I can actually just okay, let's still use print statements. Okay, so so I'm just going to say you use the word remove. Okay, so what do you want to remove? I can say I want to remove, let's take out blue. I kind of don't like danger. So after taking out the blue, let's now see the list. Okay, let's now see what the list looks like. Okay, yeah, so blue, after taking out red, what we now have is this. We have white, blue, and then we have what? Gray. There's also this method called RemoveAt. So RemoveAt actually, what you pass in as a parameter is the index. That means you want to remove an element at a certain position. Okay, you want to remove an element at a certain position. So I can actually just update this guy and say, okay, fine, remove at. And then at what position I can say, so how many do we have? We have 4, 0, 1, 2, 3. So let's say at the third index, let me still remove red. 0, okay, sorry, yeah, 0, 1, 2. So yeah, 2. Sorry, that should remove red. Okay, so let me run this. Okay, and then we have the same results. Okay, so what did it remove? Okay, we had this. So we have this. So after removing, it removed red, and then this is what we now have. Okay, and then let's see what other method can we actually make use of. Okay, there's a clear method. Okay, so basically what it actually does is to clear the list. So okay, let's just do this. So let me say dot clear. So this should now give us an empty list. Yes, this gives us an empty list. Okay. So this is actually, well, this is actually this returns an object. So that's why you don't print objects. That's why we have a Kotlin.unit. Okay. And then what else? What else can we do with a list? So this is basically that. Now, another questions before I move over. Do you have any questions? Okay, so in the absence of none, let's continue. So in a list, okay, we can actually loop through a list. Okay, now basically when you want to perform an operation on each item in a list, you can actually loop through that list. Looping means you're iterating through the list. Okay, so this will take us to talking about loops in Kotlin. Okay, and we'll start with the while loop. Okay, one of the types of loop is called the while loop. So a while loop, it actually starts with the with the keyword while. So let's let me just show us. Let's just look. So while, this is the while loop. Okay. So it takes while, and then it takes an expression, and when that expression is, if that expression is true, when it's true rather, it actually runs whatever you actually put in here in between in this scope. Okay, so so it just contains a block of code, okay, that actually executes over and over again as long as this expression is true, okay, any code you write in here will keep on executing it, to keep on running over and over again. That's what loop is what all about. So to actually prevent it from prevent the code from executing forever, okay, which is actually called an infinite loop, okay, the code block must actually contain logic that changes the value of the expression, okay, so that eventually when the expression will be false, you can actually stop executing that loop, okay. So let me just give us so let me say, look at the typical example, while 1 is less than 2, print line true. Okay, so let me comment this out for now. Let me just comment this out. Okay, so we want to actually just look at a while loop. So what am I saying here? While 1 is less than 2, print true. So that means this line of code will keep on running on as long as this is true. Now ask yourself, is 1 less than 2? Yes. Is there any time 1 is going to be less than 2? No. You understand? Except you do something about it. So if I run this, okay, running this, it gives us actually why it's actually saying out of memory, because it keeps on running and running and running. That's why you have this out of what error and Java heap space on everything. So the code keeps on running and running until, man, there's no space again. Okay, that's an infinite loop, but we can stop it. Okay, we can stop it at some point. Let me use this. So I can say while, and then after it runs the first time, I can say, okay, so let me do something. Let me create a variable, val num equals 5. Cool. So let's try something. So I want to say while num, which is 5, is less than let's say 7. Okay, while num is less than 7, print true. Now num which is 5 is always greater, is less than 7. So if we run this is also an infinite loop. So we need to check. That's why we said to prevent it from running an infinite loop, okay, it has to contain a logic that will change the value of that expression. We need to make this value to be false at some point. Okay, so how can I make it? So if I increase num, okay, then that means at some point num is going to be greater than 7. So that means at some point num less than 7 will be false. So I can increase by doing num plus plus. So that means it checks if 5 is less than 7 is true, it will print out true, and then it will run this line of code, and this line of code is going to increase num. So num will no longer be 5, but it will now be 6. So we should see true, I think, twice to run this. Okay, so val cannot be reassigned. Okay, yes, that's because you're going to be increasing, you're going to be changing the value of what num. So yes, we need to use a var. Okay, and then I'm going to run this. So we have true. So the first time it was, when it ran, it was true, and then it decreased it, and this became, the num now became 6. Is 6 less than 7? True. Increase its num became 7. Is 7 less than 7? False. It ended the loop. So that is how you actually end a while loop and prevent it from going into an infinite loop. Okay, so let's actually now try to do something much more detailed. Okay, much more detailed. So let me take this out. Okay, let's not use, so let me just take this out. Okay, I want to create a val, and let's apply it to lists. Okay, that was not a list. So guests per family. I want to create that kind of variable, and I want to create a list of, this is an immutable list. You can't change it. So 2, 4, 1, and then 3. Okay, so the concept is this. Okay, let's assume you're organizing a party. Okay, so you create a list where each element represents the number of guests. Okay, that's, you know, if you're doing rice and stew, very plenty, RSVP. Okay, from each family. So let's say the first family adds 2. The second family have 2 guests. The first family 2 guests. The second family, 4 guests. Okay. The third family just take 1 guest, and the fourth family, okay, 3 guests. Okay. So we can actually figure out how many total guests there will be. Okay. So basically, what we'll just do is to write a loop to now know how many guests that we will have. We can actually write a loop to do that. So I'll just create before that, or let's say after, I can now create a variable called total guests. Okay, and initially total guest is 0. If your party have not started, okay, or maybe it has started and they haven't started coming, your total guest is 0. Okay, now, and then I want to have an index. Okay, I want to have an index that I'm going to use to look through this list. So I can actually also create an index variable and call it and assign 0. Remember, your index always starts with 0. Okay, so what else? So I can now, with this, I can actually write my while loop, and I'd say while the index is less than our, let me just get this, while the index is less than our guests per family dot size. Remember, it actually has a size. So we're comparing the index now. So 0, okay, the size of the family is what? The size of the family is 4, right? That's the size. So while the index is less than 4, that's basically what we are saying here. So what do we want to do while the index is less than the family size? Okay, that's the number of the total number. Okay, what I can now do, I can now say, let me do something. Say total guests. Remember, I created a variable. Total guests. Okay. Will now be plus. Okay, so I want to introduce us to something now. Plus equals guests per family. I think I had that copy. Okay, yes, guests per family, and then I'm going to pass in the index. Okay, so, and then after that, I increase the index. So I'm going to explain that, so in case you feel, okay. So basically, what are we doing? Okay, I want to get, within this loop, okay, I want to get the elements of the list at the current index. Okay, and then I'll add it to the total number. Okay, I'll now add it to the total number of guest variable. So I'll add, when I get the index, I'll add it to the total guest variable. Okay, so now this, okay, is the same thing. Okay, let me duplicate that. This is the same thing as saying total guests equals total guests plus this. So these two things are the same. This is just a shorter way of writing it. So at first, this is 0. So we will now say 0 plus the particular number of guests at this index. Remember, our guest per family is a list. So the first family has 2. So we'll now get the number of guests in that index, which is 2. And then we'll add it to this 0. Okay. And that means our total will now be 2. So when we are coming back again to do it, of course, our total guest is 2. We'll go back again to the list, look for the next family, get the number of guests in that index, add it to what was there before. What was there before in the total guest is 2. 2 plus 4 becomes 6. That means this variable gets updated. So we just created a total guest variable that will be updating. So we're basically adding new values to it. Okay, so these two things are the same. You can use whichever one you want. So let me just comment this out. Okay, so after doing that, we'll now increase the index. Okay, it's because when we deal with this index, which is 0, we need to increase it by 1 so that we'll go to the next element. Okay, so after this while loop, I can now print a result. That's when it's done looping through all those. I can now print a result and say total guests count equals, and then I'll call my total guest variable. Okay, so let's see what this does. I hope I didn't make any typographical error. Yeah, so we have total guest count equals what? 10, which is 2 plus 4 plus 1 and plus 3, giving you what? A total of 10. So that's basically what looping what does, okay? That's basically what looping is all about, okay? Now, another type of loop is that we have is what we call the for loop. Okay, a for loop it makes looping through a list a bit much easier, okay? And it actually starts with a keyword for. So this is actually how, say, for example, for number in number list. Okay, just do something. Okay, do something. So a for loop actually makes looping easier. So it's basically saying for a particular element in a particular list, okay, or better still, for each element in the list, do something. For each number in a list of numbers, just do something. That is basically how I can actually put that. So let's actually use a for loop now. So I'm going to just clear this. Okay, I'm going to clear this. Let's just clear this all. So I want to create a variable. I'm going to use, let's create a list rather, since we are working with list. And I'm going to say list of, so let's use, okay. So I'm going to use names. So let me use IK. Who do I have on this call? I have, okay, so let's not make that mistake again. Fola. Sorry, this should also be. So I have Fola also. Who else do I have on this call? That's a very short name. Okay, good. I have Judah. Judah. Do I have one? Let me take one more person. Okay, I have Peace. Good. Let's just take short names. Okay, good. So I just created a list of what Android learners in KodeCamp, a list of Android developers. Let me not call you guys learners. A list of Android developers in KodeCamp. Okay, so let's use a for loop now to iterate through this list and do something. So I can just say for. I can now say name in names. Print line. What do I want to print? Print name. So let me run this and let's see the results and then I'll explain. So this is it. So it basically says for name in names, print that name. So what is it going to do? This can be anything. Okay, we just use it. I can actually say for X, print X, and run this. We'll still have the result. So this, we just use whatever name you want to use here, whatever the thing wants to name. We use it to iterate through the list. Okay, so let me just, okay, let's leave it as X. Okay, so for X in names, print what X. So X now becomes what you use to iterate. So it comes in here and it picks this element. So for this element in this, print that element, it comes back. So it goes again. It comes back to this loop to check if there's another thing in the list. It comes and it sees Fola, it prints it, it goes back again. Do I see Judah? Yes, it prints it, it goes back again. This. And then until it goes back and there is nothing else in that list, then it's what stops. So that's basically the for loop. Okay, it actually just makes looping a bit much easier. Okay, so there are various variations to this, but let's just put it all together. Now I want us to now look at this from the class point of view, because like I said, we're going into recycler view. So let's look at actually making use of this in a class. Okay, so I want to create an open class. Remember, we've talked about making a class open. So making it open means it can actually be inherited from. So I want to name this class item. And then I want this class to have as part of its property, a name of type string, and then have a price of type int. Okay, that's just what I want the class to have, just those properties. That's just what I want. Okay, now I want to create another class now, noodles, a noodles class. Okay, so this noodles class is going to now inherit the item. That was why I made the item open. So item, and then since inheriting the item class, it also I have to provide these these parameters. Okay, so let's give, so I'm going to say noodles because the first is a string, and then the price, let's say the price, let's say we want to get super pack, so 100, let's just use 100. Now I can also create another class called vegetables to inherit the item, and then also let me just call this vegetables. Okay, and then let's say 50 naira, that's the price. Okay, so so sorry about that. This should not be done in the main method. So shouldn't be done in the main method. Thank you. Okay, good. So in our main function now, let's create an object of the noodles class. So I'm going to say vals noodles with a small letter. Okay, let me create an object. So noodles, and then I'm going to call the constructor, and that creates the object. Same thing, I'm going to do vegetables. So I just want to show you guys something, and then I'm going to call vegetables. Okay, good. And then I want to print now. I want to do something very funny. I want to print noodles. Here I want to print. So at this point, I want to ask a question. So whoever has an answer should. So what do you think will be the result of this print statement? Who can tell me? Can anybody actually just, what do you think will be the result when I run this print statement? What do you think will be the result? So what do you think will be the result of vegetables? Okay, let me make it vegetable. Okay, vegetables is fine. Nobody? Okay, so let me run it and let's see. Okay, so this is what we have. When we want to print noodles, this is what it's giving us. We want to print vegetables, this is what it's giving us. And some of you will be like, okay, what's actually happening here? What's happening here? Okay, so let me explain this. Remember, this is actually an object. Okay, this is an object. We have created an object, and now you want to print an object. Okay, so this is also good to note. When you print an object, okay, when you print an object, it is the object. There's a method that is actually called when you want to print an object. That method is called the toString method. Now in Kotlin, every class automatically inherits that method. Every class, the toString method. Okay, so the default implementation of this method is that it returns the object's type with the memory address for that instance. So this is the object type. The type is of noodles, and it gives you the memory address. That's why I see this at gives you the memory address of for that instance. Okay, so we can actually override that method to return something more meaningful. Okay, something that makes more sense. So how can we do that? So in the noodles class, all I'll just do is I'll now say override. Okay, override. And what do I want to override? What function? The function's name is toString. Okay, and this toString method. No, when you're actually writing it in Android Studio, so in fact, when you're using some of the IDEs like IntelliJ IDE, the Android Studio, some of them will just give you autocomplete. Okay, so this returns a string. Okay, so let's So what do we now want to achieve? We want to override it. And what do we want to return? I want to return name. So it is the name. So what is this name here? This name is this young man, because this young man is this young man. Okay, so we're overriding this method. So we don't want to give, we don't, because like we said, by default, this method returns the object, the type, okay, the object type with the memory address, but we don't want that. Just give us the name. Okay, this is what we want. We want to just name. So I'm going to do the same thing here for the vegetables class. Paste that. Okay, and then let's run that and let's see. Good. Now we have what? Noodles and vegetables. Okay, we have noodles and vegetables. I can't actually say, just in case you're wondering. Let me just show you, just in case some of you're wondering. Okay. Okay, I can't call for price because price is integer, but this returns a string. Okay, infer type is int, but string was what's expected. So, but remember, I've actually done things where we actually converted it, well, it to string. So is it possible here? Let's try. Let's try. Let's see if this is possible. Let's try and see if this is possible. Okay, so let me take this. I like to actually just try things out. Let's run and see. Yeah, so it actually works. So when you convert this to a string, it actually works. Reason is because this method returns a string. So I can actually just do the same thing. Okay, so that's actually one of the things I wanted to, note, okay? So the next thing we're going to do, let's now, let's do a bit of, let's customize the vegetable method, object rather. So here, instead of having this, let's give it something. So let me take this out. Please ask a question, okay, if at any point you need clarity. So let's give some vegetables, let's say carrots. Let's say onion. Let's say cabbage. Okay, good. So let's just do that. Let's initialize the instance. Okay. So if I try to run this now, we'll have an error, and it says too many arguments for public constructor what vegetables defined in vegetables. So you have too many arguments here. What I was trying to say is, look, when you created this young man, this class, it takes only two things: string, a string and an integer. But here you're giving me 3 strings. That is too many words. Too many what do you call it? Too many arguments. Okay, but actually, in this class, actually, we didn't even give it any constructor, but it is inheriting just this. So the too many arguments, basically now for this vegetable class, it refers to this. Okay, pardon me, it refers to this. So it doesn't even take in anything at all. And yet you want to now pass in something. How does that work? Okay, so we can actually just, work that out. So let me just, I can now do this by now saying val veg, let me just use short form of type string. Okay, that's one. So we need 3 of it. So I'm just going to, okay, 2, and then 3, good. So that actually, so with that now we are safe. With that we are safe. Okay, so let's compile again and see if we have any errors. Okay, good. So what is it saying here? It's now saying, wow, conflicting declarations. Okay, string, and everything. Okay, so there's a whole lot of conflicting declarations here. So what is it actually trying to say? Okay, now for us to make this actually work, so instead of using using a property for each vegetable, we can actually just get a list of vegetables, okay, just a list, okay, in this our constructor. So why don't we can actually just do something like this. I can just say, okay, let's close this. So sorry. Okay, good. So I can just do something like this and get a list. Okay, so this is one other thing I can do. Okay, this is one other thing I can do. Okay, so let's now look. Let's see. So I think that's that. And then let's try this. Okay, so we have so now we have a type mismatch. Infer type is string, but list string. So here now we actually have to give a list. Okay, so how do we do that? We can actually just say list of, and then just take this guys out and put it there. Okay, so we are good. It compiles. That we are actually not printing out anything. So we are good. Okay, so that's actually you creating, having a class to hold a list of things. Now the reason I'm going here is because of what we're basically going to do when we get into recycler views. Okay, so it gets best to show us how to make use of these things also. So another thing I want to there's actually a better way of actually doing this. There's a better way of doing this. There is a modifier called VAR, variable argument, which is vararg, that allows you to pass a variable number of arguments of the same type into a function or a constructor. Okay, so in that way, you can actually supply different variables as individual strings instead of a list. Okay, so this is basically it. I can just say, instead of var, I'll just say vararg, that is a variable number of arguments, okay, immutable, and then I wouldn't have to use this again. So with this now, I don't even have to use this also. So let's run this. And we're fine, there's no errors. So we are fine. So this is, like I said, it allows you to pass a variable number of arguments, okay, of arguments of the same type. So if you look at, with this now, you can actually put 8, 9, 10, 15, 20, as much as you want because of this modifier, variable number of argument, but it has to be of the same type. It has to be of the same type. That's why we explicitly said it should be of type string. So now let's modify our toString method for this class to return these vegetables, to return this young man. So I'm going to just, instead of returning price.toString, okay, so let me use, let me just join stuff. Okay, let me just introduce us to something. So I'm going to say return. Sorry, I already have return there. Return name. Now I want to add something. Then you have topping, veg. Then there's a method called join to string. Okay, so basically what I'm trying to do is I want to actually I want to modify this toString method so that I'll return a string that also mentions the vegetable in a format of carrot, onion, cabbage. Okay, so I'll start with the name. Okay, with the name. Okay, and then I made use of this join to string so that it returns it's actually what joins all the veg together into a single string. So we use this operator here, okay, to just add a space between them. So this is not addition, okay. When it comes to string, this is what's called concatenation, okay, joins two strings together. So we're basically doing this and we're saying, look, add a space. So this will join two strings, and then it's going to add a space between between them. Okay, so let's actually test that out, and then let's see what we have. So okay, so let's see. Unresolved reference. Okay, vague. Okay, I think we need to check. Okay, expecting an expression. Okay, so we have is expecting something here. Okay, so let's see. I think probably we're making. We will skip something. Okay, return the name. Okay. So let's okay. So return this name. Yeah, that should be it. Okay, and then okay. Yes. So we concatenated name and this, but we did not add a concatenator. So this actually. This should actually solve that. Yes. So we don't have any issues. Yeah. So we don't have any issues. Okay, good. So so let's actually see the results of this. So let me print let's print vegetables, right? Vegetables. Okay, so run this. Okay, so it actually gives us the vegetables. Okay, so it returns the name. So the name is what vegetables, that's the object type. And then carrots, it gives a space. Okay, the name plus the space. This is a space here, this is an empty string. Okay, and then so this is concatenation. So you have name, space, you have the space, and then you have the word string. So it now takes the whole of this as a single string. It joins to string. So it joins all of them to one string altogether. Okay, so that's actually that. Now we can actually do some stuff, okay, to our I can actually write a code to just play around. I can say if veg dot is empty. Okay, if it is empty, so that means if there is no element there, there's no value there, just I can say return let's see, I can just say return name. Let's just return name. If there's nothing, just give me the object type, which is name. But if there is something, then just give me everything. So this you can actually play around, play a lot. So let's say if I take this out, that means I'm not putting anything there. So when we run this, what do we have? We just have vegetables because of the if statement, because it's empty. That's why we have vegetables. Okay. Okay, so now let's just do one last thing. Let's do one last thing, and then we will round up the class. Okay, so I want to create an order. Okay, this is an item. You have noodles, you have vegetables. So if you want to create an order, we have food items now. Remember, these are items. These are food items. They all inherit the item class. So every food, every item has a name and a price. Okay, so the noodles have name and price, which is inherited here and everything. So what if we want to create an order? Okay, so and then you have, so now let's look at the logic, okay, of everything. We want to create an order class. What I want to be the properties of an order class? Okay, so at this point, I want to get people to talk. I want us to talk. We want to create an order class now. Okay, so someone that wants to make an order. What are the properties you think that an order can have? Like every order now, what property do you think they must have? Somebody? Yeah, go ahead, namesake.
Okay, I feel you should have the food that is actually going to order. So I guess the class of the noodles and vegetables.
Okay, so Okay, so I want you to be specific. Like you have you come into a restaurant, for example.
Okay.
You have you can make an order. So what's that? So assuming we want to create an order, what is that thing? What's that property that every order will have? That's what I'm asking. So I want to look at properties now. Just like every item has a name, no matter what that item is, and every item also have a price, no matter what that item is. So what we want to now create a class, an order class. So what properties will actually be prevalent no matter what the order is?
Price.
Okay, well, an order, yeah, okay, price. I can go with that. What else? Who else has some? If you have something else, but who else have something else to drop?
I think item.
Item, okay. Yes, the particular item, okay. Any other person? One more. Okay, so let's move on so we can round up. Okay, so first, I think an order, one of the things it can have is an order number. Okay, like something like a number to identify what order is. Okay, order 1, order 2, order 3, order 4, order 5, and the whole and the likes. So that is one thing that every order will have, an order number. So this helps you know that, okay, fine, the first order, this is what the person wants, second order, third order, and the rest. Okay, so let's actually put that in practice. Okay, let's put that in practice. Another thing that an order can have is the list of items. Okay, so when you're making an order, okay, I need Indomie, give me Indomie, give me egg, give me bread. So that's also a list of items, okay? And then every order also at some point will have what? A total. The total amount of the items. Okay, so let's implement that. Okay, so we'll focus on properties first. Okay, we'll focus on properties first, and for now the two properties we have are I want to just use now is the order number and list of items. Okay, now let me ask this also while I'm actually creating this order class. What methods, based on the fact that we have this list, these properties, order number and list of items, what methods do you think this class can have? Somebody just open up your mic and talk. What methods do you think this order class can have? Remember what a method is, okay? Series of code that does a code, pieces of code that do a particular thing. It's just a function. So maybe I should say, what function can this method, can this class have? Method, function, they are basically synonymous. Anybody? Okay, that's fine. So methods that we can have here, for example, to add an item. Adding an item is a method. Adding multiple items is a method. To even print, for example, printing the order summary, including price, is a method. Removing an item from your order list is also a method. So those are functions. There's a way to actually do it. You need to perform certain operations to do them. Remember, we're actually dealing with a list. Okay, so well, I've just done the basic one of the properties, which is the order number. And then another property is the list. So now I don't want to create this. I don't want to pass in this list here. Passing in this list here means that when I create an object, I must give it an order number and the list. But I don't want to do that. I want to just create every order, just have an order number, and then the list can be empty, depending when it is being used. Okay, so so just look at it like this. It's just like you printing. Let's say your order is you have it as a list where people tick it. So it's just like you printing your order, and that order has a number, then you give it to someone. So on printing it, that order has only an order number property. So until it fills it, the other one can actually be filled. But on creation, you need order number. So let's say, so now let's make this a private val, and then I'm going to say item list. And this item list is going to be a mutable list of item. So a mutable list of what item. So yes, and we'll have to call this. So what is this now? This is a mutable list of what item. Remember the item class that we already have. So it's going to be a list of every what item. That is basically, that's what is going to be stored in this what item list. Okay, that's everything that you have in that your restaurant. Okay, we'll have it in the lists. Okay, so we can now add methods. So I'm just going to add, let's just say add item. So now this add item is going to take in a parameter, let me call it new item. And this new item is going to be of type item. This is not going to be of type int again, it's not int something. So every item, a new item is going to be of the type what item. So if you want to add something, if you want to add an item, you're already adding an item that is already a type of item. So basically, if you want to add bread, okay, of course, bread is part of the items that they have. It's part of the stuff. It's part of what they have already. So you're adding a new item. So that bread is an item also. And then we can another function. We can just say add all. Maybe you just all these some of all these movies that you watch. They go to the bar, then they say barman, give everybody, everything. So you just want to give out, you're in a good mood, and then you want to give out everything that is in the that is in that bar. Take all your drinks, share it to everyone. So this is add all. So you want to add you want to create add everything in that. So this add all will return a list of what the items, because you're taking everything. It's going to return a list of the items. So this is how we're actually working this stuff out. And then lastly, we'll talk about a print function to be able to print orders. So I'm going to say a print, I'm going to call the print function, okay? And then for now, I'm not going to implement it, just going to leave it empty. Okay, so for this add item, it's very simple. How do we add an item? It's to just call, remember, we already have an item list, okay? So what we just do is to just say item list dot add. And what are we adding? We're adding the new item. That is what we're adding here. Okay, the same thing applies to this item list dot add all. Okay, since it's a list, it has that method. And what are we adding? This one, new items, because this new items is a list of also whenever we call this method, whatever you pass in here is going to be passed in to this place also. Then for the print method, we're going to implement it in a way that it will print a summary of all of all the items and their prices to the output. Okay, so first thing to print out, the first thing we would want to print out is the order number. So I'm going to say print, and I'm going to say order number. So let's put it as, let's make it a bit, so order number. So I'm going to just do this, and then I'm going to add, okay, and then I'm going to call order number. Okay, so okay, sorry, this should not be capital letter, it should be small letter. Okay, so the next thing we want to print is the total. Okay, but for now we don't have a total, so we'll first of all initialize it to 0 because we'll be adding. Okay, and that variable is going to be changing. Okay, okay, I hope I am doing okay. Okay, so let's move on. Items. Okay. Okay, so now the next thing is, okay, so let's now add this. how do we now add? So we use a for loop here, and then I'm going to say for item, this can be anything. This particular variable that I used to iterate through a list can be anything. So for item in item lists, remember this is our item list, okay? So for item in item list, that's for every item in there. First of all, I want to print something. I want to say, let's say I want to print the item first. So after printing the item, then I'll print the price of that item. So I'm going to use, because I want, well, let's just use capital letter N for Naira. And then I'm going to call the price. So I say item dot price. Okay, so remember, because our item, we can actually get the price from it, which is everything actually boils down to this place. So when you create an item has a name and it has a price. Okay, because our item here in the item list is a mutable list of what item, and each item has a name and a price. Okay, so now after that, what next do we do? Okay, so we should get the total. So how do we do that? I'm just going to say total. I'm going to add and then assign at the same time. Add and assign the item dot price. Okay, so to get the price, add it here, get the next item in the list, get the price, add it here, and that's how it's going to keep moving. So after it's done, let's now print line. So the total, so I'm going to say total. I'm going to say, let's use Naira with an N, and then I'm going to now call total. Okay, so let's actually now see how this works. Okay, now remember, we have not actually done anything in our main function. So let me just run this to be sure that I don't have any errors anywhere. Okay, so I don't have any errors anywhere, so I think we're good to go. So now, how can we now test this out? So of course, we created classes, so we need to create an object of the class to be able to use certain things. So let me create a first order. I'm going to say val order 1, and then I'm going to create an order. So, but our order class takes what? It takes an order number. So I'm going to pass in 1, okay? And then I'm going to say order 1 dot, I want to add an item. And what item do I want to add? Now, I want to just add noodles. This is the item I want to add, noodles. Okay, I want to add what? Noodles. So let's now, okay, then let me now call the print function that we have, which is order 1 dot print. Okay, good. So, and what I can do, let me just print line, print an empty space. So let's just create 2 orders. I think that will be fine for now. So this, let's make this 2, make this 2. Okay, so for this one, I want to add, now I want to not just add this. I want to now add vegetable for my second order. I want to add what? Vegetable. I've added noodles. Now I want to add vegetables. I think it's vegetables. Yeah, vegetables. Good. I want to add vegetables. Okay, and then print. So that's order 2 dot what? Print. So let's actually see what this code does. Okay, let's run this. And then what do we have? Yeah, so we have order what? 1 just like we created here, order 1. So this one here, remember when we created this hash sign you're seeing, okay, it's the order number and everything. So when you're calling the print function, it calls this is order. This is the first thing it does when you're calling the print function. It prints order and then adds this and then the number. Okay. Then the next thing is what, for it to get the item list. So 100 of type 100. So what are we adding here? What are we doing? Okay. So it added noodles. Okay. So in add item, what are we doing in item? We're adding a new what item. Okay, so for item in item is basically what it wants to put. Basically, what we want to get here is the price. Okay, we want to get the what price. So that's why we now have this, and then our total is this. So the second time, vegetables, 50 naira, and then it's okay. So this is giving us 100. So let's see. Okay. Okay, so I think, okay. Someone is correct. Thank you very much, Emmanuel, for that. Okay, that's supposed to be add all. Okay, thank you very much for that. Okay, so I think I need to. So let's debug this. If you can see, when we added vegetables, we have vegetables and then we have the price. But when we added for noodles, we are having 100 and then on the price. So why are we having this? So let's see, order 1, what are we doing? Add item and then we have noodles. Okay, so let's go see what that noodles does. Okay, so yeah, we have not taken this out. So let me just do the same thing here so that we get the name. Okay, so name and then, okay, so we don't need this. So just return name. Okay, so let's run this. So we should have, yeah, noodles. So the first time it creates an order after adding the item, and then we now called what print. So it added noodles, and then the price is 100 naira, and then printed gave a space. The second order, of course, after adding the noodles, it added the vegetables, and then we can see it, and then it printed out the total. Remember, so that's actually basically that's actually that. So we will actually really use this a lot when we get to recycler views. Okay, when we get to recycler views, so that is going to be on Tuesday. So from Tuesday, man, we're going into deep stuff. We're diving deeper, building something a bit more complicated than what we have been doing. Okay, so that's actually basically that for me. Let's see, how is there a thing what we can actually do to maybe improve our code? Well, we can actually keep a list of orders. That's another thing we can do. We can create a list to store orders actually. So how can we do that? Well, I can actually just create a list here. I can just say val, and then we say orders list. I'm going to create a mutable list of, and then I'm going to pass order. So this is me creating a list of orders. So after creating a list of orders, I can now store this stuff in that list. So after adding adding an item, I can, well, instead of printing, can just say orders list, which I created, dot what add. And what am I actually going to add? I'm going to add order 1. Yes, I'm going to add order 1. So I can do the same thing to I can do the same thing for the order 2. Okay, after adding, let's not print yet. Let's just add it to the list. Okay, so and then that's actually, that does it now. And yeah, so So with this, I can now actually just print out to get the list of everything I need. So, but how do I actually print out? I cannot say print line and then say, okay, let me show you. Let's just say, assuming I now say print and I say order list. So let's see what this will give us. So when I run this, okay, unresolved reference order, okay, orders list rather. Okay, so let's run this and then see. Okay, so it actually just gives us order and then the address, because what we are printing here is what? An object. So we can't print an object. So this is a list. So we need to actually print, to actually do any operation, we need to what? Iterate through it. Okay, so I'll use a for loop to do that. So I'll just say for order in orders list. What do I want to do? I can now call order dot the print function that we created. And then I will now do a print line. So this is just basically to do. So remember, these are orders list is of type what? Order, okay? And this print method, of course, is accessible in the order class. So running this now, we should have what we had before. We should have what we had before, okay? So yes, which is actually that. So that's just trying to make things a bit more easier. So the last thing I'll just do, I think that should actually be the last, yes, is to implement what we call builder patterns for orders, okay? So you can actually use builder patterns to create orders. The builder pattern is actually a design pattern in programming, okay? It actually allows you to build up a complex object in a step-by-step approach. So instead of returning, maybe a nothing or units from, like, for example, the add item, okay, this item, okay, so instead of, for example, returning unit or nothing from these two items method, okay, we can actually return a changed order. Okay, we can actually return a changed order. So instead of returning, when you add, maybe call this method, you keep on adding, we can actually just return a changed order. So basically what I'm saying is there's a keyword Kotlin provides, this, to actually reference the current object. Okay, so what I'm just going to say, so within the add item, I'm just going to basically say return this. So what it's going to do is immediately it adds a new item, it will now return a changed and updated, a changed order. That's basically what it's going to do. Okay, I'm going to do this for the same thing. So after adding all, return, okay, return this, and this there is the object instance, okay, the current object. So how can we actually now implement that? Okay, so let me just show you what we would actually do, and then I am done. Let me create one order. I'm going to say val order 3. Okay, so now it will be equal to, and then I want to call my constructor, and I'm going to pass 3, and then sorry. Okay. Okay, so passing 3 because it wants 3 orders, and then I'm going to say dot add item. So this is me actually going a bit. I'm just making it one line of code. Okay, dot add item. Okay, so what do I want to add? I want to add noodles. Okay, and then what again? Dot add all. So okay, let's just say dot add item again. So what item do I want to add? I want to add vegetables. Okay, so for the vegetables now, I can decide that. Remember, we used var_args here. Remember, we used var_args for our vegetable, right? Yes. So that means I can put stuff if I want, actually. So I can actually put stuff there. I can say cabbage. Okay, so this is me just, okay. So after then, I'll now say my order list dot, what do I want to now access, dot add, and then let me just add my order 3. Okay, so basically order 3 is actually going towards this young man is going to return an order instance. Okay, so which you can actually call, okay, because it's return an instance, you can actually now call the add item noodles on, you can actually call the properties on the class. Okay, now the add item method returns an order instance also, okay, with a new state, so you can actually call it again. So it's actually you're just returning a changed order, of which after changing order, you can actually call it again. That's why we can even call it with vegetables. Okay, so the returned order actually just you can actually just store it in this variable. So when we so we can now add that to the list. This should be order 3. Yes, that should be order 3. Yeah. Okay, so at this point, we actually don't need to store the order in a variable. So I can actually just say dot add instead of doing this. Okay, I can actually just okay. So well, this is actually fine. I can just before I can actually create another order here. Okay, I can actually create another order. I can decide to do this order list dot add, and instead of creating a variable like an object instance, I can just do this. The order class, and let me say 4, and then so I can just do dots, and I can call the add item noodles. Okay, so actually you can actually do this way. After this guy here, then you have a dot. I can call the add item. I can call vegetables. Okay, so I can actually just do that. So let's see. I can just put this up for. So let's see what this does. Let's see what this does. And okay, so yeah, we need to say to type mismatch. In fact, unit was expected. So I think I made so this closes out. Okay, I thought this should not. Okay, yes, dot this. Okay, so I think let's see. I've done a lot actually. Okay, so we have this return this. So type mismatch expecting an element, classifier does not have a companion of the right. Okay, so let's see, dot add item, and then you add the noodles. Okay, so we're actually supposed to close this out. So we are done with that then. Dot add another item, which is this. Okay, and then closes that out. Okay, so we're doing a lot of things in one actually. That's actually why. So so let's see from the very first. Let's start with the very first. Okay, so okay, yeah. So yeah, I've seen one of the issues. Now here we're saying return. You're asking it to return something. Okay, you're actually to return something, but you're not really being a bit more explicit. So that's one thing you need to actually look out for. We are saying return this, return what exactly? That's why it's saying it's expected something else, but you're giving it something else. So we need to specify what it should return, and what it should return is an order. Yeah, that's what it should return. It should return an order. So same thing here, return an order. Okay, so that cancels out the issue we have on this. So what other issue could we have? Okay, so unresolved reference order lists. Okay, so it cannot see this order lists. Why? Where is my main function? Okay. I hope I'm not closed. Okay. So this is the okay, orders list. Okay, good. So I think so orders list and not order list. Okay. Okay, what else? Do we have any error? Okay, good. Classified noodles does not have a component and thus must be initialized here. Okay, so we forgot to add this. Okay, so I think that actually solves that. Okay, good. And we still have our results just the way it was. Okay, so yeah, this seems like a lot. So you can actually just take your time and watch the video again. I'm going to be uploading it on YouTube. Okay, take your time, watch it because it needs these basics. And of course, at any point you can reach out to me and then get to talk more about what you may have issues understanding. Okay, so but we have actually gone taking much of the time that we have. So I'll just entertain one or two questions and then we can call it a night. So if you have a question, please just go ahead. Okay, so I think we don't have any questions. Okay, fine. So, okay, so thank you guys very much. Thank you very much. Okay, Fola, you have a question. Go ahead.
Okay, so I was going to ask if we could override the toString function as the other item class, as the parent class of the other.
You can override the string function of this one.
Yes, we could do it here. Okay, right.
Yeah, you can do that. You can do that.
Yeah, and if we did it there, do we still have to override it again as other classes?
Well, I actually like that question. So we'll try it out. We'll try it out. And give us feedback. Okay, so okay, Emmanuel, you have a question out of this class. Okay, so okay, so just you do that. So thank you very much, everyone, for your time, and so that will be all for today. Okay, so